Hey all, today we're going to start going into detail a little bit about the addition rule. We talked about or probabilities when we talked about the general rules of probability, and we talked about being able to just add probabilities if they were mutually exclusive or disjoint. But today we're going to talk about what happens if they're not mutually exclusive, meaning they can happen at the same time. So we have what's called the general addition rule. The rule we were using before is just this piece where we're adding two probabilities together. Remember, this says we want to know the probability of event A or B happening. And so if event A and B can't happen at the same time, then we can just add their probabilities together and get the probability that one or the other happens. But if there is some overlap, if they can happen at the same time, we need to subtract out this piece where they're happening, this and, where they're happening at the same time. Because if we don't, then that means we're putting more into the probability than we should. So that's best shown using an example. Here we have the scenario of college students where we have some students who live on campus. We have some students who participate in a meal program. And then we have some students who do both. Not everybody who is in a meal program is going to live on campus. Not everybody who lives on campus is going to participate in a meal program. It's not a requirement. So we have this situation where some do both, but not all of them. And so we want to know the probability that a randomly selected student that we see lives or eats on campus, so one or the other. And so we can write it like this. I'm going to say live, use the or symbol, eat. And so because we have this overlap, this both, that means that these two events are not mutually exclusive. They're not disjoint. They can happen at the same time. And so we have to go and use this general addition rule because we can't just add the probability of one to the probability of other because there's an overlap. So it's going to look something like this. We're going to take the probability that we live on campus, add to it the probability that we eat on campus, which really is the meal program. And then we're going to subtract from that the probability that we do both, live and eat on campus. And we have all those probabilities from this setup. There's 56% of students, so 0.56, live on campus, 62% have a meal program on campus, and then we'll subtract from that the overlap, the 42% of students who do both of those things. And some quick calculating gets us 0.76. That means if we were to randomly select a student at this university, there's a 76% chance that that student lives or eats on campus. So either they live on campus or they have a meal program. One way that we can deal with problems like this is by using a Venn diagram to help us visualize the overlap. So you should have experience with Venn diagrams. We have two events and there is an overlap. When the two circles overlap, that means they are not mutually exclusive. That means they are not disjoint. If those two circles didn't overlap at all, then that would be a representation of mutually exclusive events. They cannot happen at the same time. But in this case, they can. We have these some students who have a meal program and some students who live on campus. And then, of course, we have those that do both. This space in the middle represents the area of students who live on campus and have a meal program. So that is 42% of our students. So I can start labeling this Venn diagram. And again, you probably have experience with this. And then we have 62% of students who have a meal program. But there's already 42% of them accounted for in this portion of the diagram. So if we want to be in this part of the diagram where they have a meal program but don't live on campus, we would have to subtract out the 42% that already is counted. So 62% minus 42% leaves us with 20%. And then if we want the students who are living on campus but have decided against having a meal program, well, there's 56% of those students, but 42% of them are already accounted for by these students who both live and eat on campus. So we'll do that 0.56 minus 0.42 and get 0.14. And before we answer these new questions, I want to show you how we could have answered the previous question using a Venn diagram and not just the formula. Living on campus or eating or having a meal program represents everything that's in one of these circles. Well, we have 20% there, 42% in the middle, and 14% in the rest of that circle. And if you were to add those up, we would get 0.76, just like we did using the formula. So this is sort of a confirmation of using the addition rule, but subtracting out the overlap because they're not mutually exclusive. If we want to figure out what is in the rest of this space, not in the circles, that means these are people who are not eating or living or eating a meal program, and they're also not living on campus. So those people who maybe have an apartment off campus and still want to get their own groceries. All of our probabilities should always add to 1, so we can subtract 1 minus our 0.76, and so this space would be 0.24. And so that would answer this question right here. Just using our Venn diagram, the people who live off campus and don't have a meal program exist in this space outside of the circles, which is 24% of students. If we want to look at the students who just live in a residence hall, so they're living on campus, but they decided against the campus meal program, we've already found that value by filling out this Venn diagram. That's this part of the circle, the live on campus circle, that is not in the overlap. So 14% of students live on campus, but they are making their food in their microwave or something. So an example of how non-mutually exclusive events that are not disjoint have an overlap. So when we want to find an OR probability where we want to add, we have to subtract out the overlap. And then how we can use Venn diagrams to our advantage to find some probabilities in these scenarios. So I have a few questions for you to answer. Make sure that you answer these. Obviously, this first one where I'm asking you to create a Venn diagram, I won't be having an answer box for that, but you should practice doing that. If you need help, make sure you ask and then answer the questions in the boxes that pop up.